This is Karthik, studying in Sri Venkateswara College of Engineering, CSEI student. Today we are going to discuss about Hough transforms in digital image processing. So let's go into the topic. The introduction of Hough transform is given. The Hough transform is a feature extraction technique used in image analysis, computer vision, and digital image processing. It is a feature extraction technique and it is used in image analysis, computer vision, and digital image processing. It was developed by Paul Hough in 1962 for detecting lines in images and later extended to detect other shapes such as circles and ellipses. The purpose of this technique is to find imperfect instances of the object. The main purpose of this technique is to find the imperfect instances of the object within a certain class of shapes by voting procedure. This voting procedure is carried out in a parameter space from which object candidates are obtained as local maxima in so-called accumulator space that is explicitly constructed by the algorithm for computing the Hough transform. This is the introduction of Hough transform, and why do we use this Hough transform? The reasons are given. Automated analysis of digital images. A subproblem often arises of detecting simple shapes such as straight lines, circles, or ellipses. In many cases, an edge detector can be used as a pre-processing stage to obtain image points or image pixels that are on the desired curve in the image space. Due to imperfections in either the image data or the edge detector, however, there may be many missing points or pixels on the desired curves as well as the spatial deviations between the ideal line, circle, or ellipse and the noisy edge points as they are obtained from the edge detector. For these reasons, it is often non-trivial to group the extracted edge features to an appropriate set of lines, circles, or ellipses. The purpose of Hough transform is to address this problem by making it possible to perform groupings of edge points into object candidates by performing an explicit voting procedure over a set of parameterized image objects. These are the main reasons for using Hough transform. And methodology. What is the methodology? Edge detection. Prior to applying the Hough transform, an edge detection algorithm such as scanning edge detection is typically used to identify the edges in the image. This step helps in reducing the amount of data to be processed and focuses on the most relevant information. And the second methodology is parameter space representation. In the Hough transform, each point in the image space is represented as a curve or line in the parameter space. For line detection, the parameter space is typically represented using two parameters, the angle, that is theta, and the distance, that is pi, from the origin to the closest point on the curve. Accumulator array is the third methodology. An accumulator array is created in the parameter space, initially set to all zeros. Each edge point in the image space is then transformed into a parameter space, and for every theta phi combination that passes through the edge point, the corresponding accumulator cell is incremented. These are the methodologies involved in Hough transform. And the next one is thresholding and peak detection. Once the accumulator array is filled, thresholding applied to identify the most significant lines. The cells in the accumulator array that exceed a certain thresholding value are considered as sequential lines. The peaks in the accumulator array correspondent to the parameters theta and phi of are detected lines. Conversion back to image space. This is another methodology. The detected lines in the parameter space are then converted back to the image space using inverse Hough transform. So we use inverse Hough transform for this. The process involves finding of intersections of lines represented in parameter space and drawing the corresponding lines in the images. The Hough transform is a powerful technique for line detection as it is capable of detecting lines even in the presence of noise or partial occlusion. However, it can be computationally expensive, especially for the large images or complex shapes. Various optimizations and extensions have been proposed over years to improve its efficiency and robustness. So, mathematical instance. A simplest case of Hough transform is detecting straight lines. In general, the straight line y is equals to mx plus b can be represented as a point b, n in the parameter space. However, vertical lines pose a problem. They would give rise to unbounded values of the slope parameter m. Thus, for computational reasons, Duda and Hart propose the use of Hessian normal form. The image is given x cos theta plus y sin theta is equals to r. You can go through the image for some more knowledge. And it is therefore possible to associate with the each line of the image a pair r comma theta. Plane is estimates refers to Hough space for the set of straight lines in 2 dimensions, and the example is also given, so you can go through the example. This is also example. So applications, why do we use this Hough transforms? The Hough transform has various applications in computer vision and image processing. Of the key applications are line detection. This is the major application of Hough transform. The Hough transform is commonly used for detecting lines in images. It is valuable in applications such as lane detection in autonomous driving, object recognition, and image segmentation. So we'll go through this once more. The Hough transform is commonly used for detecting lines in images. If you want to detect the lines in images, then Hough transform is used. It is valuable in applications such as lane detection in autonomous driving, and it is also valuable in detecting the lane in autonomous driving, like self-driving, automatic driving cars, object recognition, and image segmentation. Circle detection. The Hough transforms can be extended to detect circles in images. So it is also used to detect the circles in the images. This is useful in applications like object detection, iris detection, and industrial quality control. And the next one is shape recognition. By modifying the Hough transform, it can be applied to detect other geometric shapes like ellipses, rectangles, or arbitrary curves. This enables shape recognition and object detection tasks. And the fourth application of Hough transform is feature extraction. The Hough transform can be used to extract robust features from images. By identifying lines or other shapes, it can provide distinctive information about the structure and geometry of objects in the images. These are the major applications of Hough transforms, and there are some more applications. The medical image analysis. Hough transform finds application in medical image analysis such as identifying blood vessels, detecting tumors, and segmenting anatomical structures. So this is also used in medical field. And the other is instrument analysis. The Hough transform is employed in optical character recognition systems to detect and extract text lines or specific characters from scanned instruments. This is the another application of Hough transform. And the next one is image registration. In image registration, where multiple images are aligned to create a composite image, the Hough transform can be used to detect corresponding lines or shapes in different images to find transformation parameters. This one is another application. Particle tracking is the another one. Hough transform can assist in tracking and analyzing the movement of particles or objects in videos or image sequences. These are just a few examples of many applications of Hough transform. Its versatility, robustness make it valuable tool in image analysis and computer vision tasks. This is all about Hough transforms. I hope you understood about Hough transforms. If you like my video, please like, share and subscribe. Thank you.